So hi everyone. No more waiting. It's time to get started. And if someone in case is a late joiner or has to leave midway or anything like that, do not worry. And the session will be recorded and the recording will be sent to the email you signed up with. So thank you guys for joining this session today. We'll be talking about building a fully operational internal developer platform in about 30 minutes or so. Most of it will be live coding, and I'm here more, and with me is Suzanne. Suzanne, if you'd like to introduce yourself.
Yes, sure. So hi, I'm Susanne Daniels, and I work with Bort as a developer relations lead. So if there's any documentation totally wrong, or you want to just hang out and chat about Bort or anything developer experience in general, you know where to find me. During this awesome, mostly demo webinar, feel free to ask any questions. I will be moderating in the chat. Obviously, it goes without saying because you're the nicest people in the world, but we ask you to be nice and friendly and kind to each other.
Of course, if you have any question during the session, feel free to write it and we'll try to get to them as we go. But we might have some questions that we postpone to the end. And also there will be time for a Q&A session at the end. So do not worry if maybe we didn't get to your answer to your question immediately as you asked it. Let's get started. So a short introduction. My name is Mor. I'm a lead architect at Bort. I come from a software engineering background. I have given several webinars over the past few months, some even with the CNCF, some with Bort, such as Introduction to Developer Experience and Abstracting Kubernetes with Developer Portals. I love video games, bouldering, and burgers. I actually didn't get a chance to have a burger with Suzanne just yet, but that is probably incoming. So
I'm looking forward to that.
Oh yeah. You have some contact information here in case you want to chat with me about developer portals or about tech in general. Let's talk about what we'll be going over today. So we went through the introduction. And now we're gonna shortly go over the core pillars of a developer portal, and we're gonna set the stage for our demo today and show how developer experience integrates with your organization and where an internal developer platform fits into all of that. And once we have that background set, we'll go into the live coding session. And now the session does assume that you have a basic understanding of how Bort works. So I will be skimming over some things more than usual. But of course, if you have any questions, if you're having a hard time following me, if I'm going too fast, feel free to type it in the Q&A chat and I'll go over things again. No worries. I don't have a rush of time. So we're gonna take it as we go and make sure everyone's happy at the end. So let's talk about the core pillars of a developer portal. At Bort, we look at 4 core pillars that we like to discuss. The first is the software catalog. That is actually the visibility and observability layer that gives you that interface for your developers, for your DevOps, for your platform teams to see everything that is happening, all of your services, all of the dependencies, all of the packages, all in one place where you can put them on a graph and actually see, okay, how do all these pieces connect? Who is the on-call for my service? What is the version I'm using for this package? Does it have any vulnerabilities or anything like that? It is your one-stop shop to get a true understanding of how does the tech stack in my organization look. Now, once you have that software catalog in place, let's talk about the self-service layer and the workflow automation layer. So self-service lets developers and other personas in the organization to consume all of the great information in the software catalog, but not just that, actually invoking existing scripts and existing workflows that usually the DevOps and the platform engineers of the organizations already have. and give developers the option to leverage them and save the need for finding the nearest DevOps in the hallway, or sending him a Slack message, or opening a ticket, or sending an email, giving some more independence to developers to make, first of all, their lives easier and faster, and giving them the option to ship code faster, but also freeing up the time of the DevOps, because I assure you, he has a bunch of scripts just waiting for that correct way to hand them over and expose them to the developer. And he would much rather do that and focus on some new work that he can do to make lives better and work better in the organization. Now, when we talk about the workflow automation layer, that is where we make the connection between the software catalog and our CI/CD and our pipelines. As time went on and we saw all of the great information that is ingested into the software catalog, we realized that machines need a software catalog too. Your CI/CD could greatly benefit from that one source of truth that has all of the information, everything up to date all the time, and use it to make decisions. Can I deploy this service? Are we in a code freeze? What is the configuration I should use for this specific deployment, et cetera, et cetera. And the idea is that by utilizing a software catalog and giving your CI/CD an option to query it, you actually supercharge your CI/CD and make it even stronger and more powerful. And let's talk about scorecards, which let us use all of that information when we ingest it and set some standards, set some best practices, and define in our organization, okay, how does a mature service look? How does a service that is production ready look? How many tickets, open tickets do we allow it to have? Maybe we want to enforce that it has a README, that it has an owning team, so on and so forth. And we have the option to set those standards and then look at them and say, okay, this service might not be up to par. We want to initiate a process. Let's say a month from now, it has to be up to the gold level. And we know that it's bulletproof, it's production ready, and we can be certain that it's going to work well for a long time with little maintenance. And now encapsulating all of these pillars is the role-based access control layer, which lets us decide who gets to see the information in the software catalog, because yes, we're going to have a bunch of great information there, but not everyone needs or wants to see all that information. I assure you that your developer probably doesn't want to see every small detail in your kube config, but on the other hand, he would really appreciate having a map showing him all of the microservices that he owns and other microservices that rely on him, because that would make his life much easier when he's working on his things. And of course, the developer portal interface is meant to be easily consumed. And in order to do that, we offer an interface either via the UI, a strong API, or chat ops. And once you have the developer portal in place, you can use our R&D insights and reports to get a bird's eye view of everything that's happening, everything that's going on, and really understanding how to push forward your tech organization. So now that we have those pillars in place, let's set the stage for our demo today. So as a platform engineer, your primary goal is to improve developer experience in your organization. Now, looking at it from your developer's point of view, they would love to scaffold new microservices themselves because it's a pretty automatic and mundane process. You already have that template. Maybe it's a cookie cutter. Maybe it's something that you made in-house for how a new Python service looks in your organization. So they don't really need the platform engineer to do that. They just need the permissions and that one script they can run, which will perform that action for them. Now, let's say that they do have that option. Okay, they scaffolded a new microservice, but now they want to deploy it and they want to test it. So they would also love an action that does that for them and deploys that new microservice as they're working on it to the development Kubernetes cluster or to some intermediate environment to make sure that everything's running okay and our new features are ready to go. And then as a final point, it would probably save everyone a bunch of time if the developers could promote their services to production when they're actually ready. But of course, promoting to production might be a bit more of a sensitive topic. So we probably want to put some guardrails in place, and we'll also show that in the session. But this is going to be the primary layout of what we're going to do today. So if we're gonna break it down by steps, we're gonna start by building an initial software catalog and using a Port's GitHub app and extending the data model. Then we're gonna set up an action that scaffolds a new service. And then we're gonna go back to the catalog to extend it with some information from our Kubernetes. And then we're gonna give some more actions to our developers by giving them the option to deploy to test, and then to promote the service to prod once it's ready. And finally, we're gonna give both the platform team and the developers that bird's eye view. We're gonna set up some scorecards, we're gonna set up some dashboards to really give everyone an idea of how we're doing in the organization, how are our services, are we up to standards, and so on and so forth. So I suggest we get to it. So this is Port, and we're gonna start from scratch, just an empty developer portal. And what we're going to do is we're going to start with the GitHub template. So first thing, when we start with the GitHub template, it's gonna ask me, am I using GitHub issues? So in this case, the answer is no, but are you using GitHub workflow? And the answer is yes. So we mark those in. Let's just go ahead and install the GitHub app. So this is my organization. I want to give access for all repositories in this instance. And of course, I need to do some authentication. Security is important. So bear with me for a second. Here we go. So we have the GitHub app installed. We can click on done. What's going to happen is that Port is going to create some blueprints for us. And we can already see here some structure. And of course, since this is one of Port's templates, it comes out of the box with a configuration that will map information for us. So we have our microservices and our pull requests. And if I go to the catalog side and open the microservices page, I can already see all of my microservices ingested inside. And these are all different repositories that I have in this GitHub organization that I used. And now what we're going to do is we're going to start extending our data model a bit. So let's say that this template already is a pretty good fit for me, but I do want to add here an additional property. So what I'm going to do is I'm going to go to edit JSON, and I have some JSON payloads already pre-made. So I'll save those in and then explain what I did. So since our blueprints are completely customizable and you can do whatever you want with them, I decided to add a type property. And this is just meant to categorize the different services that I have in my GitHub organization. And now that I have this information inside, I can go and assign a type to some of my services. And of course, this time I'm just showing how to do it manually. But of course, everything is API first. You can make the update through GitHub, for API, through Terraform, whatever works for you. This is just to show you the process of maybe I'm doing something from the UI, maybe I need to do a small fix or just make sure that the data is correct. So everything can be done through the UI. Now we're gonna add a few more blueprints, and over the course of this demo, I'm going to add quite a few blueprints, and I will explain over time how they all connect. So now I'm starting to build like a more higher level overview. So I'm going to create a domain blueprint, and I'm also going to create a system blueprint. And I'm also going to create a relation between system and domain. And this is my way of creating a given a sort of architecture for how this example organization behaves. So, of course, your organization might look a bit differently, and you might want to model the information in a different sort of way. But this is the beauty of Port, that you can also map things out in a way that works for you, in a way that makes sense for your organization. And you can extend the data model in whichever way makes sense for how you are used to work. And now let's go ahead and create some entities in these new blueprints. And again, these will be manually inserted. But of course, we can always use the API to ingest more information or take it from different sources. And if you wait just a few more minutes, we're gonna show exactly how those new sources look. So let's go ahead and create that. And now we have a new domain called subscription. And if I dive in to see the information that I put in, so it has a description, but one important thing that it has is an architecture diagram. So this is a property that I saved on this blueprint, and I added a URL here. So in this case, it's just a small demo diagram, but of course, imagine that you want to include a complete architecture of your entire system or your entire domain in this instance. So you can 100% put that here. You can even attach it to some outside source, for example, a Notion page. And that way, when that Notion gets updated, and this page also gets updated, so people always have the latest architecture to refer to. Now we're going to create a system. And again, I already have these JSON payloads ready made, just to make things a bit quicker. And you will notice that since I have that relation between system and domain, I already mapped that in here. So now when I go into my authentication system, I can already see in the related entities view which entities is connected to. And we can also put that relationship on a graph. And as time goes on inside this demo, you will see how this graph gets filled with more and more relevant data. Now, let's talk about self-service. So we said that we want to give our developers the option to scaffold a new microservice. So let's do that. Let's add a new action. So we'll just go ahead and pop this in. So we have a new action for scaffold new microservice. And how this action is going to work, it is going to use a GitHub workflow to make that scaffold process. So if I go to the self-service hub, I can see here the scaffold new microservice action, which I just created. And it already has a set of inputs that I configured. And of course, you as the platform engineer, your job is to create this form that the users see and also put the different guardrails in that make sense. So for example, let's say we only work with Node and Python in our organization. So we can limit the different inputs that we can put in this language field. And what we can also do is make a requirement. So you have to fill in the value of the language field before you can fill in a version. And also that version is derived. So we only work with Node 16 and Node 18. But if I switch to Python, then I will see the different Python versions that we work with. So my action actually requires quite a few inputs. So I'll just put those in and I'm going to click on execute. And you can already see that the action has started running. And this is directly working with the GitHub organization that I connected in. So you see, after just a few seconds, we already have a job link that we can go to. And we can see this scaffold action running. And it's not doing anything too complex. It's just going to use cookie cutter with the parameters that I gave it to scaffold that new microservice. And if we look on the side of Port, then we can see that we have some logs flowing in. Because as part of this workflow, I'm also using Port's GitHub action to report on those logs and report the status. So we can see that the action is completed successfully. We can see all of the logs. If we want to go back to an old action to see how it ran and what happened with it, we can also see the payload that was sent. So this is the exact payload that GitHub received. And once I clicked on that execute button, and I can also see just the user inputs. And if I go to the affected entities tab, what I'll see is that I have a new microservice called off service. So this is a new repository in our organization, and I can, of course, browse to it to see it. I can see that it was created just now. So this is an example of how we started with an empty developer portal, and we took it from just empty, no data at all, to the point where we already have a lot of information. We already have all of our microservices. We already have pull requests and our workflow runs and all of our workflows. And we even started looking at creating that high-level map. So if we want to gather our bearings and see where we're at, we made it this far. We only got 3 steps down. And now it's time to dive a bit deeper and bring some Kubernetes information in. And of course, remember, if you have any questions, feel free to ask them in the Q&A chat, and we'll get to them and we'll answer. I hope I'm not going over this too quickly. And I really am trying my best to explain things, even though I assume that you have some understanding of how a blueprint works and how a relation works and how the different systems connect. So what we're going to do now is we're going to use another template. We're going to use our Kubernetes template, which again, it's just going to ask us a few questions. So in this case, it's going to ask if I'm using Argo CD. In this instance, I am not. So I'm just going to go ahead and click on next. And again, this will go and create those blueprints that we can see in the background. And it's going to ask me to run these few commands to install the Kubernetes exporter on my Kubernetes cluster. So I actually have 2 different clusters for this demo. So I'm going to deploy the Kubernetes exporter on them now. So if we switch to my terminal and I go ahead and perform this action, so this script is going to run. It's going to just take the Helm chart for ports Kubernetes exporter. It's going to install it on our cluster. So this is my test cluster done. And now let's do the prod cluster. And once this completes, we're going to start seeing some Kubernetes data inside our port. And I can see a question from Matan asking, could you give some more information about what system and domain represent in this use case? So we're modeling here a complete organization architecture. And we're saying, okay, we have a domain. A domain is a high-level section of the R&D of the company, some major service and major functionality. So in this case, we went with the subscription service. And inside that service, we have a different set of systems. So in this case, we have the authentication system. And once we're a bit deeper into the layout and how we extend the model, you'll see that we'll start connecting a few more things to the system blueprint. And then it makes a bit more sense because you'll see how everything ties together and how everything works. And we'll, in the end, we'll get a really nice overview of everything that's happening in the organization. So now like I said, we ingested our data from Kubernetes by installing the Kubernetes exporter. So if I go to the cluster view, I can see my test cluster and I can see my prod cluster. And if I go to the workloads, I can see all of the different things that I have running in my cluster. So in here, I'll see deployments and I'll see replica sets. And of course, I'll see them from both clusters, but I can 100% filter this out and say, okay, I want to only look at test now. So it'll filter it out and only show me test. It can just as easily say, show me all of the prod stuff. And we get that, no problem. So if we look at it now, we say, okay, we have our information from Git. We have our information from Kubernetes. And now it's time to tie everything together. So what we're going to do is we're going to create another blueprint. And this time it's going to be the environment blueprint. And this is where we're going to start seeing things coming together. So now we have our environment blueprint. Let's go ahead and create some environments. So we're just going to create some environments that match our clusters. So we have a prod environment, and we're also going to have a test environment. Excellent. And now that we have those in, let's start tying everything together. So what we're going to do is we're going to go to the workload blueprint and create a relation from it to the microservice blueprint. And what this relation will help us do is it'll help us map every workload, which microservice is it a deployment of. So our microservice is more of a static entity. It is just our code sitting in a repository, but a workload is an actual running instance or a running service of our microservice. So that will give us that visibility view showing us, okay, this is my microservice, and these are all of the different environments that it's running at. So we can actually get a bird's eye view of what is happening, where and when, and what is the status, is the service healthy, and which cluster is it deployed, and so on. And I can see a question from Miro asking, so linking blueprints is like linking tables with a foreign key using the same name on both tables. Yes, so that is actually quite similar. The idea of the custom data model that Port provides is somewhat similar to a database. The idea is that you can select exactly what information you want to see for every entity or for every blueprint. So you model those blueprints according to your needs. And then you make those connections between them. And those connections can be a one-to-many, it can be a one-to-one. So in this case, the relation that I did from workload to microservice is a one-to-one relation because every workload can only be a deployment of one microservice. But of course, if we're looking at something like the microservice dependencies, a single microservice might depend on multiple other microservices in my organization. So that is a case where you would use a one-to-many relation. Okay, so let's continue with extending the data model. So we're gonna make a new relation from cluster to environment. And of course, this relation will let us see where does each of our cluster is running on which environment. And of course, we can extend this to be a cloud environment or a cloud region or whatever we might need to actually create that complete view. And we're going to do two more relations. So bear with me. We're going to make a relation from microservice to system, which is how, like I said before, we're going to see how everything ties together. So now we will see a connected graph. So if I go ahead and shrink everything, you're going to see that we have nice connectivity from every point in the graph. And one last thing we're going to do is we're going to connect workflow run to workload. And what this will let us do is it's going to let us know for every run of our workflows of part of our CI/CD, we're going to be able to see what actual running service was deployed. So if our, like we said before, our goal is to give developers the options to deploy their microservices to test and deploy their microservices to prod, then by using this relation, we're going to be able to actually map, okay, this specific GitHub workflow ran and it deployed a service. Let's look at that service that was deployed. Okay, it's this deployment in the workload blueprint. Okay. So that is all of the relations that I wanted to create. And I can see another question from Sam. After you finish the config via the UI, can you export everything to Terraform and RAC format so we can store it in Git? Yes, 100%. So our Terraform provider is very powerful and you can 100% start from scratch just with Terraform. And we have seen some of our customers do that and use only Terraform to configure everything from the first blueprint to all of their entities that document their different cloud resources. But you can 100% start with the UI, gather your bearings, understand how the system works, and then start migrating those things to Terraform or to GitOps. We do see customers sometimes go with that approach because it is a bit more easy to see things visually before diving into the infrastructure as code. Okay, so now that we have all of our data model extended and connected, I'm going to do just one last thing. I'm going to extend the workload blueprint. So I'm going to dump a big JSON here, but really almost nothing has changed. I will go over the changes. So what I did is I added a endpoint property, which is going to include the URL of the workload and exactly where we can reach it once it's deployed. And I also added a calculated property for Swagger URL, which is simply going to take that endpoint URL and add a /docs to it in the route. And that way, the moment we go to that URL, we get our Swagger and we can view it, and we can share it with other people from the organization. And that way we don't have to look around for how can I see how to use this API that I see in my organization, and I really need it for one of my new features. So no more guessing game. You can go to this view and look at the Swagger URL and just make use of it. Okay, so we have our data model completely extended. And now what I want us to do is I want us to add an action that will deploy a new microservice to the test environment. So we're going to, again, go to the microservice blueprint. We're going to go to the actions and say, add another action. Now, I just added an action called deploy to test. And one thing I want to show you is exactly how our form works. So in here, you can see the user inputs object, and you can see the properties. So every property is an input inside the form. And I added here a cluster input because I want to know to which cluster am I deploying this new microservice, because I might have multiple test clusters and I need to select between them. But since this is specifically the deploy to test action, what I'm going to use is I'm going to use a filter that says, I only want to see clusters that have test in their name. And of course, you can take these conditions and do whatever you want with them. You might have a more specific or less specific condition to apply. But now when we go to the self-service hub, we can see our new deploy to test action. So let's go ahead and deploy the notification service and deploy to the test cluster. In this instance, this is the only cluster that we have. And let's click on execute. And you'll see that, again, this just starts running right away. I didn't use any specific manual approval step or anything like that. So it just starts. And again, we can see a new job link for this deploy to test action. And we're going to give it a few seconds. It's going to take about a minute to run. But the end result that we'll get eventually is we're going to have some logs here showing what happened in the action. So you can see them flowing in right away. And what's going to happen in the background with this action is it's going to deploy a new service in my Kubernetes, which in this case is an EKS cluster. So I can see that the deployment has completed. And if I go to the affected entities, I can see that I have a new workflow run. And now, why do I have that? This action triggered a GitHub workflow. So we have a new GitHub workflow run. And we can see here that we also have a new entity for this workflow run in our catalog. But if I go and look inside that workflow run, we can already see how it connects to the rest of the graph. So like I've shown you before, I created a relation from workflow run to workload. And that gives me the option to map here the workload that was deployed. So in this case, I deployed the notification service on the test cluster. So what I can see here is I have a new workload, notification service test. And since I have that connection, I can also see what workflow does this workflow run belong to. And I can also see the namespace that this workload was deployed in. And I can see the microservice that belongs to this workload. So like I said, this gives us the option to see exactly where is my microservice deployed and where is it running at any given point in time. And we can go all the way up to the cluster point of view. So this shows us how we started maybe 30 minutes ago, I'm not sure. And we started with a blank developer portal. We mapped our services. We used GitHub. We scaffolded a new microservice. And now we actually have it deployed in test running. Our developers can get to work. And the next time they want to do this, it requires zero effort on their side. So now what I'm going to do is I'm going to show how we extend the information that we take from the Kubernetes exporter. So what I'm going to do is I'm going to update the config in both of my clusters. And I'm gonna go to the code to show you how this config changed in just a second. But what I'm going to do is I'm going to deploy this updated config in both of my clusters. And what's happening here is, let's just see the new config for test. So what I actually added was the part where you see in the comments. So I added for every, there we go. Yeah. So I added a new relation to service for every deployment, so we can see its respective microservice. And what this will give us is the option to actually see for every workload the microservice that it belongs to. So you can see here now that for the different services that I mapped, for example, the payment service and the product service, then we can see the service that this deployment belongs to. And this makes it very to see where my service is deployed. So if I go to the payment service and I look at the workload view, I can actually see that I have two workloads of this service. One is in the test cluster and another is in the prod cluster. And again, this gives us that bird's eye view, that very simple way of understanding how are things working, and where is everything running, and so on. So what I want to do now is I'm going to add another action. So we already have the option to scaffold new microservice. We already have the option to deploy to test, but what about promoting a service to prod? So let's add an action exactly for that. So again, I'm just going to put in some action definition here. And this action acts pretty similar to the last one. Again, I added a specific filter for the inputs. In this instance, I want to see just the prod clusters. But one extra thing that I did is since this is a promote to prod action, and it might be a bit more sensitive, it might require a manual approval step. So I marked it as require approval true. And in addition to that, I can also specify how I want to receive that approval. So in this case, I went with Slack, and I simply put in here a Slack webhook URL. And now, once I go to the self-service hub and I say promote to prod, all I have to do is look at the service that I want to deploy. And I can, of course, only see the prod cluster because it's filtered. I'm going to click on execute. And what's going to happen is I just received a message in my Slack. So let me just find that and show you guys. There we go. So we can see here a new request for approval. And once I click on review request, I'm going to immediately go to the page for this new action run. And of course, if we look at it from the platform engineer hat, then I have the option to approve it. But let's say that we were a developer using this. So we invoke that action, and now we're waiting for our DevOps or our platform engineer to approve it. We do not have the permissions to approve it. Maybe our team manager or team lead has the permission, but usually this would be reserved to the admins of the developer portal, which are usually the platform team or DevOps team. So in this case, this action is okay. I'm gonna go ahead and approve it. And once I do, it's gonna start running. And this is pretty similar to what we've seen before with the test action. It's actually doing a pretty similar process. It just needed that extra manual approval step. And it's going to be deployed to our prod cluster. And so while that is happening, I actually want to show you some additional result of the updated Kubernetes exporter config that I deployed. So if you recall, I mentioned that I added a new endpoint property. So now it is here, and it is reported by the Kubernetes exporter because I added it to the config. And now we can see our actual service running. But in addition to that, I also added that Swagger URL, which is a calculated property which simply takes this URL and adds a /docs to it. So now if I'm a developer and I want to learn how to use this service, or I want to prototype something or test it inside the test environment, I can simply click on this URL. It's gonna take me to the Swagger UI. And now I can see all of the different routes that this service provides, and I can develop with it and work with it and continue working on my features without having to dive too deep into any sort of documentation. So I can see that our action has completed, and we have our logs again and showing what happened exactly, and we can see that it succeeded. And now when we go to the affected entities, again, we have a new workflow run. And if we look at that, we can see that it deployed a new workload for notification service in prod. And again, as before, we can go all the way up to the cluster view. But we don't have the complete picture just yet. And we're going to do that in just a second. Before that, I want to recap to which point we got so far. So again, we started with an empty portal. We added the GitHub app. We started ingesting some microservices, and we extended the data model quite a bit. We set up an action that lets our developers scaffold a new microservice. Then we started ingesting information from Kubernetes using Port's Kubernetes exporter. Then we set up an action that deploys a microservice to test and one that promotes it to prod. So now we have that complete chain from the moment the microservice is born up to the point where it's deployed in prod and it's serving our customers and it's giving value. And now, once we have that service running in production, we want to see how it's doing. We want to see that it's up to standards. And so now it's time to set up some scorecards, set up some dashboards, to really tie everything together. So I just want to run one tiny thing that's gonna update some information. As you might remember, I created a relation between microservice and system, but I actually did not perform a map of that relation. So you can see here that system is empty. So I'm just going to run a simple script that's going to make that update and make sure that all of our microservices are mapped to our system. So in this case, all of the microservices that we see here are mapped to the authentication system. And once I hit refresh, because my script has finished running, what we will see here that this entire column has been filled. And you will see why that is important in just a few minutes. What I want to do now is actually add some nice scorecards to see how our services are doing. So let's go to the Dev Portal Builder. And let's go to the scorecards and let's add some scorecards. I'm not going to go over the structure right now. What I'm going to do is show you the end result, which is how our scorecard looks once it's deployed. So you can see that I created 3 3 different rules, one in the bronze tier, one in the silver tier, and one in the gold tier. And now once I go to the microservices view, and let's just hide a few columns to make it a bit easier to see. So if I go to my notification service, for example, I will be able to look at the scorecard and see, okay, this scorecard, this service, the notification service is at the bronze tier because it only passed all of the rules up to the bronze level. So it does have a README, which you can actually see here. But the language it is using is not supported in the organization. And while it does have an owning team, it actually didn't pass all of the rules for the silver tier. So it is stuck in the bronze tier until fix it. So this is an example where we can see a service that is not up to par, that is maybe not up to our standards. And we can say, okay, it's either that we bring up support for this language in the organization, or we migrate this service and we do a refactor, we go to a language that we do support. And this makes it easy to understand how are we doing, how is our tech debt doing, what can we do to improve ourselves as an organization. And also we get that complete view in here if you want to see it, exactly how each service is doing with the ownership scorecard and the different parameters that we look at. Now, what I want to do now is I want to add another dashboard visualization. And in order to do that, I actually need to create some new information. So let's just go into my repository, and I made ahead of time a pull request and just updating the README of the notification service. So let's go ahead and merge this. And now we're going to have a closed pull request, a new pull request in our developer portal. And what I'm going to do now is I'm going to go to the microservices page, and I'm going to add a new visualization for a number chart. And what I'm going to do is I'm going to add a cycle time chart. So cycle time basically means the average time from the moment a pull request has been opened until it is merged. And in order to track that, I'm going to look at information on the pull request blueprint. And I already, the GitHub template comes out of the box with a calculate property called cycle time in minutes. So I'm going to make use of that. We're going to average over it. And we're going to say that this has a custom unit of minutes. And once I create that, I can see that I have a cycle time metric that I can look at. So let's say that this is an actual microservice that is very active. It has plenty of developers working on it, opening pull requests. People need to review those. People need to fix conflict and eventually merge. So over time, this metric will contain the latest information and the best information, and we can look no further than this dashboard view to actually see, okay, what is our cycle time? Is it high enough? Is it low? Why is it maybe lower for this service than most others? Maybe this service is much harder to support. Maybe it's much harder to develop for, and so on. So this is the kind of view that we get. And the last visualization that I want to show you is actually the one that really ties everything together from start to end. Let's go back to our domains blueprint, and we can see here, first of all of the connections that we made across the graph. So we can see our system and our microservices and pull requests and workflows and workload and so on. And we can put it on a graph and see how this entire web of services is working. And we can actually hide certain pieces that we maybe not care about so much at the moment, and really narrow down the view until this graph gives us the best information to understand, okay, how is everything interconnected? How does our organization work? What can we maybe do to improve it? So this is that visualization that gives us all of that information. But what I also want to do is I want to add a tech radar pie chart. So a tech radar simply shows us the different tech stacks that we use in our organization and how common is each one. And so in this case, I'm going to create a pie chart that's going to the microservice blueprint. It's going to use the language property. And once I save this, there we go. We got a pie chart showing us all of the different languages that we use in our domain. In this case, we can see that we have a lot of Python and some Shell and some JavaScript. But of course, as this organization grows and as we ingest more data, we can see how this domain does relative to other domains that we might have, and see, okay, maybe this domain is moving a bit slower. Let's see why. Okay, I can see it in its tech radar. It's using maybe an older language or an older framework, and I want to improve that and change that. So these are the kind of conclusions that you can make by utilizing the reports and the visualizations and the scorecards that the developer portal gives you. And of course, you can dive into these views from whichever point that fits you. So if I want to look at a specific service and again, see how it connects in the graph and all of the different places it is running and the different processes that deployed it and so on, then we can 100% do that. And eventually you arrive at a point where you actually have a full-fledged developer portal. It has actions, it has all the data, it has Kubernetes information flowing in real time. And it's always up to date. It's always containing less information. It's saving time and cognitive load, both for you as the platform team and for your developers, because they have those actions, because they can do things on their own without having to request permission or without having to understand exactly how that script is working, and you just expose it to them. And this is the insane power that Port gives you as a developer portal, as an internal developer platform. So that concluded our final step, and I believe I just recapped everything, but to go over it again, started with a blank portal, added the GitHub app, extended the data model, and we set up an action to scaffold a new microservice. We added some information from our Kubernetes, which is always live, always giving us real-time information. We set up an action that lets our developers deploy those new microservices to test on their own without any help at all, and then promote them to prod with just a simple manual approval step that goes to their Slack. And now we have scorecards in, and we have dashboards in. So we have that complete bird's eye view. We can see exactly how our organization is doing, what is happening, and we can take this forward and say, okay, let's improve maybe things that are not up to par, and let's keep going in this direction. Let's add more information, add another layer on top of this. So really, the sky's the limit. And this is just to show you how quickly you can get a developer portal up and running. And that concludes the live demo section. So this is time for a Q&A. If you have any questions that you might have not had the chance to ask during the session, feel free. We'll be here for a few more minutes. I also highly suggest looking at demo.getport.io to see our live demo. It is completely open, no sign up, no email required. You can see how a fully fledged developer portal looks, with information, with actions, with full scorecards and dashboards. So you can really use it as an inspiration and understanding where your developer portal can take you. Okay, so I can see some questions. So we have Anonymous asking how to avoid Terraform state lock issue when multi-self-service action triggered. This is something that you would usually use a simple backend with locks on. So maybe an S3 bucket to store the state and a DynamoDB table to make sure that the different workspaces are locked properly. So you're not running multiple actions on the same workspace at the same time. But of course, you can also say, hey, if this Terraform action is a bit more sensitive and I want to make sure that it doesn't run immediately you might change the process to open a pull request instead of simply performing the Terraform apply, and that might make things more manageable for you. And so that is a way that you can approach that issue. And I can see that Mero also has a question. Do you plan to build an Ansible executor when calling a self-service action? Also an Ansible module doing callbacks? Yeah, so we do have plans to add support for Ansible in the future as well. It is on our roadmap. I do not have a precise ETA to share on that, but we do have plans to add that. And I believe that will answer your question and make things simpler for you in the area of using your Ansible to trigger self-service actions and to make changes in your infrastructure. And Mero also asked, are you going to allow to pass a JSON payload and credentials to a webhook trigger? So when we're talking about webhook actions, you can really pass whatever input that you want, the form that you saw me configure. So maybe in this instance, this is completely customizable by you. You can transfer whatever information you want and need. We are currently working on adding a secret type input, which will be the correct place to pass in some credentials that the backend that the action goes to might need, whether that is a GitHub action or one of your APIs or Lambda functions, or maybe a GitLab pipeline. So yes, that would be the way to do it. And we are adding support for it. Okay, so I'm just going to give 1 or 2 more minutes for people to send questions if they have them. In the meantime, I would like to remind you that this session is recorded. So if you missed anything, if you want to go over it again, if you want to go over things more slowly, don't worry, we're gonna send you a recording of the session. Once it's uploaded, should be probably a day or 2 at most. And you can go over it as many times as you want. And like I said, feel free to email me or hit us up on our intercom inside port. If you have any questions, we'll be happy to help you out. Okay, so I see a question from Simon. Do you have a roadmap for self-hosted solution? What is the most popular self-service backend at the moment? Okay, so we do have plans for a self-hosted solution. It should be available in Q3 of this year. We are currently working on it. And we will for sure update in all of the proper channels once it's available for you to deploy and make use of. As for the most popular self-service backend, I would say it is probably the webhook backend, simply because it's very versatile. You can connect it very easily and prototype with it in a very convenient manner. But we also see plenty of customers using GitHub workflows because it simply integrates very naturally with the CI/CD processes that they already have. So that is a pretty strong second runner. And Meru asks, can you make a gist of all the JSON used in this demo? Yeah, so I will also upload a public repository containing all of the different snippets that I made use of in this demo. It will include the complete flow of what I did, including the blueprints definitions, the action definitions, the different Kubernetes configs that I used, and so on. So that would make it very easy to follow through if you want to recreate this exact thing on your end and get started with a portal that looks just like this, then you will have the option to do that. And I can see that we do not have any more questions coming in. So again, thank you guys so much for joining this session. I hope you enjoyed it. And we'll see you guys in the next one.